How do you figure out if your data is normal, if there are any outliers, or what the average really means? In today's video on Python Day 5, we are diving into the essentials of data analysis. From calculating percentiles and range to understanding the central tendency of your data with the mean, median, and mode. We'll also tackle the measures of dispersion like variance and standard deviation and wrap it up with some cool data visualizations to bring your insights to life. And by the way, if you're really serious about AI and machine learning and want to go deeper into data analysis, we have got a free live AI and machine learning masterclass coming up. And that will give you hands-on experience and help you apply for these skills in real-world scenarios. We have helped more than 45,000 individuals land their dream jobs. So you can register through the link given in the description below.
Okay, so suppose I have got 15 values. I'll just keep it simple. First thing, for the percentile, you arrange everything in order. Then suppose if someone tells me how many people above 80 percentile. Listen to my question. I'm saying how many people above 80 percentile. So what do you need to do? Look into how many observations do you have. So I have 15 observations. So take 15 into 80% is 80 by 100, which is 0.8, right? So 15 into 0.8 will be how much, guys? 12. So if someone says how many people above 80%, so just to give an example, how many people are earning salary above 80 percentile? Okay, I hope you're getting. Or suppose if someone is saying what is the 80% salary that you have, 80 percentile, so you will automatically say 8,940. Is it okay? So what will people understand? Below this, how many are there? They will understand, okay, there are people who are earning less than 80 percentile, 8,940. There are 80% of the organization people who are earning less than this, and there are 80% of 20% people who are earning more than this. Is it okay? So if I say above, you will consider from here, right? If I say below, you will consider from here. Is it okay? I'll give you a case. I'll just put it simple. I have 200 employee information, okay? 200, okay? And all are arranged in sequence. Now, if I ask you, tell me 40 percentile value of this 200, what are you going to do? 40 percentile? 200, 40 over 100, 0.4. So tell me what will be the value? 20 into 4, so 80, right? Is it okay? So now you will look at the value. Suppose this is the value at 80. Okay, so someone is asking, what is the salary earned when you have 40 percentile? Okay, so you will come to this 80, you will say the salary earned by people who are at 40 percentile, okay, is 7210. So you'll say, okay, 60% are below this, right? This salary, and 40% are above this salary. Yes or no? Is it okay? Simple. It's a simple thing. Now let us just take a odd number. Suppose if I say 20, let us just take a random number. 22, and if I tell 30% of 22. So 0.3, then what will be the value? 6.6, right? So where is 6.6? You will go ahead and say, if someone says 30 percentile, okay, tell me the 30 percentile. So you will say between 6 and 7. Okay. So you will say 6 to 7 direct. Is it okay now? Directly you will use a value of 6 to 7. Okay. Or you can put it to the next integer. See, if someone says, what is the 80 percentile salary value? If you say 1 lakh, then people will understand, okay. Okay. So there are 20% people who are earning above 1 lakh. Okay. And there are 80% people who are earning below 1 lakh. That's more of a understanding of the orderedness, okay, with the help of percentile. We get a fair idea, right, of with respect to value. So someone will say 80% people are between 8,800 to 8,900. Just give an example. That's okay. I'm getting a fair idea. Okay. There are 20% who are earning more than this 8.8 to 8.9, and there are 80% who are below. So where do I fall? I'll also suppose you got a salary of 6,000, right? Just give an example. So you will fall. Okay, I fall under those 80% people, right, who are below. Making sense? Just having a overall estimate about place where I hold. This is how ranking is placed in the exams also, right? Percentile. Now, what is percentile? The value below which a given percentage of observation in a group fall. Okay. So 80 percentile. Below, you can say above, that's okay. Category. Now, what is range? You all are aware, difference between highest and lowest value. To give you a simple thing, this range here was 2, 6, and 20. Okay. So which can give you much clearer picture whether we should go for standard deviation or not. Okay, now the very important thing, guys, this is going to open your mind with respect to how things are being observed. And on the basis of this, we also have a plot called as box plot, a very important plot. Okay, now there is something called as interquartile range. Just to give you an example, I'll tell you why this is important. You'll get an insight. First, try to understand how does it basically function. So suppose I have got, right now you understood percentile. The purpose of percentile is to understand how many are above, how many are below a particular range, a particular percent. Now comes to interquartile. Interquartile is basically something related to median. So what do you do? First you arrange. How do you work with median? First you arrange all the value in either ascending or descending. What is this? I'll just help you understand. Keep it simple. First you try to find the median. Arrange everything in sequence. Either ascending, descending, it's your wish. Median will always be median. So right now I've arranged everything in ascending order. After that, find the median value. So if it is even number, median will be, I told you, mid of 2. Right now, it is a odd. So my median is what? Tell me. My median is 8. Is it okay? 8. Now, above this, there is a range, and below this, there is a range, right? Okay. So right now, we have divided the data into two halves. First half here, and we have one half below this. Simple. Okay. Now, after this, how much is left? Here, 7, right? Now, take a median of this 7. What will be the median of 7? 4. And what will be the median here? 12. Okay. Is it fine? Now, what we have done, we have divided this data into how many parts? 4. Via 3 lines, we will divide it into 4 parts, right? This is called as IQR. Okay. Sorry, this is called as quartile. This are called as quartile. Quarter. Quartile comes from the word quarter. So you divide your data into 4 quarters. This gives you much more clearer picture. And now, why is the significance? You will understand. Now, if someone says 50%, tell me the range of the people who are earning between the interquartile range. That means people, and I'll tell you, this is what, see, wherever, if you have a range in ascending, this will become Q1. Okay. This will always be Q2. Okay. If you have a range in ascending, this will be Q1 and this will be Q3. If you have arranged in descending, top will be Q3 and below will be Q1. Okay. Now, if someone says, tell me the range of quartiles. So this is where the quartile starts and this is where the quartile ends, right? So the range of quartile will be Q3 minus, tell me, Q1. Okay. Now, if someone gives me this value, so I will understand 50% of the people are falling under this much range of salary. The difference I am able to understand for 50% of the organization people. I hope that makes sense, right? This is where the chunk resides, right? What I'm saying, what is the range of the salary that people are earning? As per IQR, 50% range. Tell me 50% range. What I'm saying, tell me 50% range. So how get that 50% range via this? What will give you this will give you a clear picture. Try to understand this will give you a clear picture of how much is the data distributed. How much is the salary distribution for 50% of people who are in the mid category. Is it okay? This is not percentile. Okay, you can call it to a way as percentile if you want, but to be very frank, there is a reason why we do go ahead and do that. I'll tell you what is the purpose of this. We'll look into this. Wanted to show you first. Where is that? Let me just show you that graph. Yeah, I'll tell you why is this important. Okay. Now just look into this. Just suppose that same data. Okay, what I had. Okay. So this is my, I have just inverted. Okay. So this is my quartile 1. Try to understand this. This is my quartile 3. So we'll try to find what was the quartile. We'll try to, what was our quartile? Can we check? So if I tell you the value, so if I try to draw a box, going to draw a box. Now let me just put it this way. This is my Q3, Q1. Let me put it this way. Generally we put it this way, and this is my Q3. Now if I tell you what is Q1, what are you going to say? 5147. Wonderful. Now if I tell you what is Q3, you are going to say 8810. Now I'll tell you we try to draw two nodes. Okay, just we draw these two lines. I'll tell you what is this. Okay, now what do? We get 50% people who are earning between this. Okay, what about people who are above this or below this? These are extraordinary, right? Either they are extraordinary or they are dull, right? Okay, so what happens next? Let me just show you this. I'll just explain you right away. What do you basically do is, if you want to see, I'll tell you, how do you find this node is very important. I'll tell you why is this important. Now, I'll just help you understand. I'll just give an example. Suppose my quartile, I'll keep it simple. Quartile is 3000. Okay. So below quartile. Okay. Here I am getting a quartile of 8000. And why is this required, this box plot? You need to understand the significance. Okay. So now if I tell you what is the range, tell me what is the range. Now I want to find this node. I'm interested. I'll tell you why is this required. I want to find this node and this node. We'll try to first find this. Okay. Now, if I want to find this node, if it is below, since this is below, right? So below value will always be minus. So 3000 minus 1.5 into 5000 will be 7500, right? So what is coming out? Minus 4500. That means this value is at a value of, tell me how much? Minus, is it okay? Now we'll come to this. This is third quartile, we will add. So what is third quartile? Tell me 8000 plus, tell me, guys, I hope you're understanding. 0.5 into 5000 is 7500. 7500 plus 8000 is how much? Tell me, try to understand what I'm saying. Okay, this value is coming out to be this. Okay, now if anyone in our data is above this, this person is extraordinary outlier. Okay, if anyone in our data is below this, this person is an idiot. Do not consider his salary to be anything important. Is it okay? What I'm saying? Right
Yeah.
now, this is negative. That means can salary be negative? No, there is no
No.
one who is below the minimum node. Can salary be positive? Yes. So there can be a person who is above. So you can consider these things to be outlier. So box plot helps you identify outlier. Is it fine now? Again, repeat. Either you use this formula, this is standard science, or you use 95 percentile to find this node. That's okay. This formula or 95 percentile. 95 percentile means what? Whatever 95 percentile. Now you remember percentile. Whatever is the number of values, take it by multiplied by 0.95. That observation, if there is someone above this, because this is a range, right? You remember? Sorry, this is a sequence. That will be outlier here, and similarly we will have outlier here. Okay. So you either go by this formula or this to find how many are between this. So this is a normal distribution wherein these people are also okay. These people are also okay to understand the system. Anyone below this, above this will be considered as box outlier. And this is what we call box plot. So if you draw box plot, there's no purpose until you understand what happens at the back end in the box plot. Okay. So I hope you understood this. Now how to show numerical data, I'll just keep it simple. You can use box plot, you can draw bar chart, you can draw histogram, frequency table. There are so many. Frequency table, I will just try to understand what is frequency table. So suppose this is the salary. Someone told, someone told me just draw a frequency table. So I'm going, first thing that we need to do is keep a range. You can draw a range. Someone can give you a range. If you remember, we used to do this in school. 1, 2, 3, and then fourth line, and then the fifth used to come, and then we used to say 5. You remember this? This was what we call frequency tally. We used to do tally, right? In the school time, I do remember we used to do tally. So I'm just creating my own category: 0 to 2000, 2 to 4000, 4 to 6000, 6 to 8000, 8 to 10,000, whatever you want to put. So I'm getting two frequent, two people between this, six people between this, four people between this, three people between this, and one people between this. Now, what are we going to do? This is our X scale. Okay, this is our Y scale. In the Y scale, what do we have? Count. In the X scale, what do we have? Tell me. Range. What do you do? Now, what is the maximum value? 6. So we can go from 1, 2, 3, 4, 5, 6. So here, what will be the plot? 2. Here, it will be 6, so it will go to the maximum, right? Next, tell me, it will go to 4. Next, it will go to 3. Next, it will go to 1. This is what we call histogram, right? So histogram is done when you have a frequency table. Is it okay? This is histogram. Okay. I hope you understood frequency table histogram. Now, matplotlib and seaborn we do for data visualization. we'll look into this. Let me just, I hope you are also okay with this. Male, female. You're getting a count, right? Male, female, two category, and we are getting the number of males and number of females. Response time in hours. Okay. 0 to 5. Okay. 0 to 1, 1 to 2, 2 to 3, 3 to 4. How many calls were made? Okay. Just to give it simple, what was the response time? Okay. For the calls that were being made in the what you can say, suppose in the call center, okay, people were calling. So how many calls were answered between 0 to 1 minute? How many calls were answered between 19 to 20 minutes? I'm just giving an example. Okay, how many frequency of calls were made which were being answered, okay, in this much response time? I hope that makes sense. So you can draw a frequency count against the category. Is it okay? This is what we call histogram. What is bar chart? It seems to be same, but guys, this is different. Bar chart is different. If you remember all the salary we are plotting to understand the things, just to keep it simple, if I try to draw all the tops, okay, this is all the salary. This is not at all. Here, what do we have? Here we have experience. And here, what do we have? Do we have count or do we have actual value? Tell me. Yes, when you take all data point and then this is how you get the graph, right? Even in your stocks. Okay. So if you do it this way, okay, draw all the lines from the center. Okay. So this is called as bar chart, trend. Okay. Trend of salary. Okay. This is not count. If you categorize them into different, what you can say, uh, suppose people who are between 1 to 4, people who are between 4 to 8, people who are between 8 to 12, and then 12 to 16, and then take a count of that, then it will become histogram. Okay, this gives you a trend. Okay, salary trend. Okay, is it increasing with experience or is it fluctuating? You'll get that idea, right? That is bar chart. I hope that makes sense. So always remember here, what do you have? You have actual value being plotted in the y-axis. This is same. This is your feature, right? But here, what do you have? You have actual values of the feature, not the count. When you have the count, you call it as histogram. When you do not have the count, when you have actual value, you call it as bar chart. But again, these are interchangeable. People play with this. But I hope you're able to make sense. Okay. So bar chart, if it is drawn in a vertical sense, it is called as vertical bar chart. This one, and this is called as horizontal bar chart. Is it okay? Now, is this a bar chart, to be very frank? Though I have put it in bar, is it a bar chart? Histogram. So I did say that these are interchangeable things. This also looks like bar, but to be very frank, this is not bar chart. Bar chart basically something, what you say is here also, if we see, yeah, this is bar chart. Okay. Is it okay? It depends. Again, I told it depends. It varies. Okay. How is this count? Is this count or is this value? Okay, that will decide whether it is bar chart or histogram, but you need to understand. Now, bar chart is line chart are same again. If you remember all the points, you have this kind of thing, you remember this, we had this, right? If you take all the centers and draw them, this is basically nothing but a line chart. Okay, same values are there. Try to understand, values are there, and here you have features. Feature can be month, it can be product, whatever it is. Okay, so then you draw. This is again taken from the bar chart only, just to help you understand. Line plot, bar plot, and histogram seems to be same, but histogram is separate. Line or bar chart, you can replace it, that's okay. Same things are coming out here. Also you have the chart. If I ask you where was the maximum sale, if this is sales, what are you going to say? In the month of June. If I ask you if this is sales, when was the maximum sales, you will say when that was this person or this month or whatever it is, they the maximum sales. Both the things means one and the same. Okay. Now we'll look into some another chart and we will try to do some visualization things also going ahead via using matplotlib and visualization. So what we have gone through frequency table, histogram, bar chart, box plot, even line plot. So today we are going to look into machine learning packages. Before that, we need to understand data pre-processing prerequisites. Okay, this is important because when we try to go ahead and look into machine learning packages, they are going to go ahead and do this kind of a work for us. So we are going to go ahead and look into machine learning packages. And when we are talking about machine learning packages, there are different machine learning packages. Some are for visualization, some are for working with data or manipulating the data. Okay, for which we have pandas and numpy, and then we also have one package via which you can build a machine learning model. So just to give an insight, the process of any machine learning model starts with data ingestion, right? So we are already aware that we have something called as, yeah, we have something called as data ingestion. We ingest the data. Okay, once we ingest the data, we would like to go ahead and visualize the data. Okay, when we visualize the data, we find some issues in the data, right? Like maybe machine learning model requires the data in a specific format, or it needs to be manipulated in a sense. Okay, so if you want to pre-process the data, okay, or if you want to do some imputation on the data, you can make use of manipulation techniques, right? So if you want to go ahead and do that, finally, once the things are all in place, then you would like to select an algorithm, right? And for that also, we do have different packages. So for data ingestion, okay, or basically once the data is ingested, this step is done. Okay, we would like to visualize the data. And for that, we can make use of packages like Matplotlib and Seaborn. Okay, now Seaborn is built on top of Matplotlib. We are going to go through this, okay? Matplotlib and Seaborn. Okay, we'll try to understand what is Matplotlib and what is Seaborn and what are the important curves that we need to be able to understand. Okay, then we will look into how to pre-process the data making use of pandas, how to manipulate the data. Suppose if I want to do some calculation, basically NumPy stands for numerical Python. If you want to do some manipulation on the numbers, you can work with NumPy. Finally, if you want to go ahead and select an algorithm to build your machine learning model, you can make use of scikit-learn. Now, the point is everything does not stop here. The packages are innumerable, and you can go ahead and select the package of your choice to go ahead and do the task. Okay, whatever task I am saying, they are going to stay. Okay, but the packages can vary. Okay, now just to keep it simple, for visualization, I told we are talking about Matplotlib or Seaborn, but there are others also. For pre-processing, we have got pandas. Okay, then for manipulation, we can make use of NumPy. We can do basic manipulation via pandas also. But if you want to do serious mathematical imputation, then you can go for NumPy. And finally, to build a machine learning model, you need to use the packages which contains those mathematical algorithm. And for that, we have something called as scikit-learn. Okay. Now let me take you ahead. Before that, if you remember, I did say that we need to understand the prerequisite for data preprocessing. Now, when I say prerequisite for data preprocessing, when we are talking about visualization of data, pre-processing of data, manipulation of data, then building a machine learning model on top of the data. What comes in your mind when we say pre-processing? Okay, I'll give you an example. Will pre-processing be related to Python programming? Will pre-processing be related to mathematics, maths, and stats? Or will it be related to cloud deployment? Okay, what will be the thing? What do you think will be the most correct, suitable answer for this? If I want to pre-process data, mathematics and statistics, right? If I say 1 plus 1, what is the main thing if you want to understand 1 plus 1 out of these three terms? You know, maths and stats, right? Everything that we want to do with
Okay.
data, right? For that, the fundamental is mathematics and statistics. So when I say pre-processing, okay, data pre-processing, we are talking about fundamentals of maths and stats. Okay, now we are not going to discuss about fundamentals of maths and stats. We will discuss as and when it comes. But for visualization, for pre-processing, for manipulation, okay, not scikit-learn, but for pre-processing, for visualization, for manipulation, we need to understand some important terminology, and that is what we are going to go ahead and see. For this, we have got a very beautiful chart, just to keep it simple. So first thing that we basically go ahead and do is just to keep it simple. Okay, we have data, right? So we have data. Okay, what do we try to go ahead and do? We try to analyze the data, right? When I say analyze the data, tell me the mean. Okay, tell me which is the most frequent value. Tell me if this data is having a normalized value across the column. Okay, just to keep it simple. Tell me if both the columns are not having that much big variant that we need to normalize it, right? So basically, whatever I am saying is with respect to analyzing and visualization. If you want to do, then you need to be able to understand mathematics, okay? So that you can go ahead and analyze and visualize the data. So we'll look into that aspect. First comes analyzation and visualization. Then once you analyze and visualize, okay, then you go ahead and build something, right? So you build something. Once you build, then you go ahead and try to connect it. Basically, you deploy it, right? Okay. Once you deploy, then you can go ahead and again collect the output. Okay. See the response. And based on that, if you want, you can again analyze the system. And if you want to retrain the system, you can even retrain the system. So just to keep it simple, when I say this, I've taken this diagram from somewhere, but I found it fruitful that this is more about first step is about analyze and visualize. Second is about build, okay, and optimize. Third is about deploy and then monitor, collect the data, monitor the data, manage the model, everything. And finally, if you again want to retrain, you can retrain or you can start from here or you can take it from here and again you can restart. That's the main thing. Okay. If the model performance is not up to the mark, you can retrain the model. Okay. So you again visualize the thing, right? And then you go ahead and act and connect. I hope that makes sense to everyone. Okay. So what is pre-processing? Just to keep it simple. Basically, this is where we say get your data ready for machine learning work. Okay, simple thing. Okay, now in this, we go ahead and do multiple steps. Like if you want to clean the data, transform the data, select some feature, reject some feature, split the data, everything you go ahead and do here. Just to give an example, I have got a data. Okay, I'll just give an example. Suppose I have got a data for loan approval, which is of a people who have already taken loan in past. Okay, so I have got loan approval data. Suppose one of the column was amount. Okay, amount that he asked for loan amount, right? And suppose there are some candidates wherein this column is null. Okay, what I'm saying, there is no value mentioned here. Suppose there are three of them wherein there is no value mentioned here. Okay, now what do you think? When there is no value, what should we go ahead and do? We need to go ahead and handle this missing values, right? Or if there are duplicates, okay, that we think will lead to overfitting of the model. That means model will go ahead and uh, based on this duplication, model can overfit. Okay. If you want to understand overfit, I'll just give an example. I'll just give an example of my school time. I do remember. So suppose there are two students, okay, who are sitting. Suppose the student is, they both are appearing for exam. This is student number one and this is student number two. You are student number two and you are sitting back. Okay. I'm just giving an example. Suppose this person is writing the paper. You know the answers. What I'm saying, you know the answers very well. You're very good. Okay. You're a champion. But this person has opened his paper. Okay. He has kept his paper in such a way that you can see everything from his paper. Now tell me, will it affect your response or not? Or will it affect your marks or not? If he's showing you everything, and suppose he is far better knowledgeable than you, just give an example. Will it affect your answers if he's showing his paper, examination paper? Now, why is it going to affect? Because you are looking into something, right? Now this is where we go ahead and call this something which is you can say outside thing, okay, or I can say this is more of you knew everything correctly but still someone was showing you something and you went ahead and tried to overfit your system. Okay, you knew the answer. Okay, suppose you looked into something, okay, and then you went ahead and copied that thing. Okay, so you can call this case to be a case of overfitting where you're looking into something. Just to give an example, I'll give you one more example, just to help you understand overfitting. Okay, suppose there are different. Suppose I want to predict the marks of a student. Okay, and if I want to predict the marks of a student, okay, on which factor will it depend? It will depend upon number of hours studied. Okay, it will also depend upon number of hours. Suppose number of hours played. Okay, it will also depend maybe number of hours slept. Okay, suppose these are the three things. Now, suppose number of hours studied. When someone is studying, suppose one person is studying for 8 hours. Okay, then he's playing for 0 hours and sleeping for 0 hours. Just giving an example. Just giving an example. Okay, student number one. Okay, student number two. When he is, suppose when he is playing for 8 hours. Okay, he is studying for 0 hours and suppose this is not so appropriate, but suppose he is on not even sleeping. Okay, then there comes third student who is only sleeping, which is making sense also. This can be a real case. Okay, and he is not playing and he is not even studying. Okay, just to give an example. Now tell me, don't you think this is a perfect match? Like for each and every student, which factor is contributing, one factor or more than one factor for each and every student? One factor. For this student also, one factor, right? And for this student also, tell me one factor, right? Now, this is a case of overfitting. Okay. What do you mean by overfitting? At the time of training your machine learning model, you showed the data in such a perfect mapping that the model can only understand that this is the only correct thing. Okay. So basically, this model is going to be biased if if it sees anyone, okay, with this 8 hours, it will automatically label them to be student number one. Okay, type of student number one. If your model sees someone playing, it will automatically categorize them as student number two. And if it sees someone sleeping, it will automatically categorize them into, tell me, student number three. I hope that makes sense, everyone. One more important thing. Suppose there is one column, I'm just giving an example. Suppose there is one column, okay, wherein we have category, okay. Generally, the category should not be more than three or four types, right? General. Everyone agrees. Suppose bank has created for the loan approval, bank has got a data wherein one of the category is type of job. Okay, okay, type of job. Is it fine? So generally the category should be how many? Three or four. But suppose you have got a data from some source wherein type of job for, just give an example, for 100 data points. How many data points? For 100 data points, basically for 100 individuals. Okay. The type of category is 50. Giving an example. Now tell me, is it feasible to consider this kind of category? This kind of category wherein the type of job are being categorized into 50 types. Is it good or bad? Tell me for the model. It's difficult, right? So what you can go ahead and do, in this case, you need to clean the data. So either you delete this aspect, right? You say, I'm not going to consider this to build the model, right? Or what you can do is you can convert this 50. Okay, you can classify this 50 into three or four types. I hope that makes sense. Maybe the 10 categories are of the similar type. So you keep them in type number one, then 10 category in type number two. So rather than having 50 type, you can have five type. Okay. Because your ultimate aim is not to predict the category. What is your ultimate aim? Whether the loan will be approved or not. So what I'm trying to help you understand, cleaning is all about working with the data and trying to fit it in such a way that the machine learning model should be good enough to give you correct prediction. Machine learning model is not interested to find how many categories. What it is interested in our case, it is interested whether the loan will be approved or not. Whether you convert those people who are into 50 category into five, machine learning model is not really bothered about it. It's only bothered about what is the output. Is the output correct? Okay. Now let me take you ahead quick. So we can transform the data. We can do some feature selection and splitting. We are going to discuss about all this one by one. Now, for this, the first thing that we need to understand is, since I told we need to understand cleaning of data, transforming of data. So there is a very important point that we need to look into before learning the package, which is about pre-processing. Okay, so we have put one aspect of pre-processing, which I'm going to discuss right away. And for pre-processing, there are two types of statistics. We are right now talking about descriptive statistics. Now, what is descriptive statistics? Statistics is a branch of mathematics which helps you understand the stats of the data, like what is the mean, what is the median, what is the mode. You must have heard all this aspect earlier in your maybe school days also, right? So we are going to study about descriptive statistics that describes your data. Before we understand descriptive statistics, let me take you through this very nice example. Okay. Now, what I'm trying to help you understand is these are called as variables. All these are basically called as variables, like loan ID, gender, a person is married or not, dependent, what is the employment type, is it self-employed or not, okay, what is the income, what loan amount has he asked for, how for what term has he asked for the loan, what is the credit history? What is the credit history? How many times has he taken the credit? Okay. I'm not saying about repaying. How many times has he taken the credit? Where is he looking to buy the property? Okay. And what should be the status? Based on the past data, we have got this information. Now, I want to go ahead and build a machine learning model which is going to predict whether the loan should be approved or not. So tell me, out of all this, what are we trying to predict? So you told this aspect, right? Now I am going to help you understand. See, any type of data variable can be classified in this world into two types, qualitative and quantitative. Okay, try to understand first qualitative and then we will look into quantitative. Okay, now what is qualitative? In the qualitative, it is not about numbers. Qualitative is about quality of the data. Okay, when we say qualitative, it is more of a class. Okay, now in the class also we have two. We have nominal and then we have ordinal. Just to give an example, male. Male will never be a number. It will be either a male or a female or maybe a transgender. Okay, these are the three things that we will have, right? Male, female, or trans. Okay, now even if you put male as one, female as zero, and transgender as two, it will still be the same thing, right? One, zero, two, everything will basically mean one and the same, right? Simple thing. Here, 102, even if we write, we do know that this might be indication of some class. Okay. So, gender. Similarly, married. Married. Okay. No. Married. Yes. And maybe divorced. Okay. There is one more condition. Just to give an example, this is also nominal data. Similarly, the person is self-employed or not. Either it will be yes or it will be no. Okay. Similarly, the property area. Where is the property? Is it in urban, rural, semi-rural? There can be so many cases. Now comes the status. The status will either be approved, not approved, or maybe. We don't know, right? That can be a third condition, maybe. So all these are called as nominal qualitative variable data. Okay. Now, what is the difference between nominal and ordinal? Just look into this credit history. Now, this credit history, to be very frank, here I have taken the credit history basically as whether how many times, what I'm saying, how many times credit was taken. Credit was taken. It can also be whether the credit was taken and repaid back or not. Okay. I hope you're getting, guys. So what I'm saying, it can also be, right now I'm saying how many times credit was taken. Credit repaid back or not. So what I'm saying, credit repaid, zero for not repaid, one for repaid. Now tell me, when I say zero for repaid and one for not repaid, does it mean quantity or does it mean quality? It is quality. And we will put it, it's nominal. Now I'll tell you why if this would have been the case, this would have been the case, right? Credit history repaid or not, it will come under nominal. And I'll tell you why. Because I'll tell you. See, if I say credit repaid, no. Credit repaid, yes. Now let me give you a very simple mathematics thing. Okay. Can you ever say no is less than yes in this case? Or can you say no is greater than yes? Or no is equal to yes? Can we ever say this? We cannot say, right? So whenever you have some category wherein there is no order in the category, then you call it as nominal category. Is it okay? Try to understand. Again, I'll repeat. When you have some category like gender, can we ever say male is greater than female or female is greater than male? We cannot say. But still it is category. So whenever you have category wherein there is no order in that category, you call it as nominal. Okay. But when you have order, like just to give an example, number of dependents, it can be zero, it can be one, it can be two, it can be 10, right? Now, can I say here 10 is greater than zero? Say that, right? But this is also a category, to be very frank, wherein we are actually, there can be many people who are having 10 children, right? Or maybe 10 dependents, right? So we can say that 10 is greater than zero is actually a category, but it is ordered category. Okay. So basically quality, when we say it is basically dealing with category. Okay. And that category can be nominal in nature and that category can also be ordered in nature. Okay. Now we'll go to the next part, which is quantity. When we say quantity, this is short, this is simple thing. It is number. Like term. This term can also be a category, but right now we are saying term for which the loan was being taken. 60 months, 120 months. Now you can even put this also here, right? You can put. Now again, I told this all depends upon how do you see the problem, right? You can call 60, all 60 you can consider to be ordinal, right? Okay, all 120 you can consider to be ordinal. That is also a case. But if you consider it to be suppose number of days in which he is taken the term loan, right? So you can even call it as discrete. Okay, discrete is basically something which is a number which is always going to be a whole number. Can you say that someone has taken a loan for 3.5 days? Have you ever heard this? 3.5 months you must have heard, but still you will not see 3.5 months, right? But 3.5 days you will never hear, right? So this type of number is always discrete. Okay. That means it will always take a whole number. So if there is any variable which is always taking a whole number which does not fall into ordinal, you can call it as discrete variable. Okay. Similarly, you have continuous variable, income, loan amount that the person has asked. Okay. This is continuous. It can be in decimal, right? Float. I hope that makes sense. Qualitative, quantitative, everyone. Now we have other type also, which you are already aware. I have told you. Suppose if I have been given this sheet and being told that please try to build a model which is going to predict the loan status for the future data. Okay, so this is our output variable. So this is what we call target. This is what we call dependent. This is what we call output variable. Okay, and whatever is there apart from this is called as independent input, or they even call it as features. Okay, based on this the target will vary. Okay, so we even call it as features. Okay, predictor hardly people use, but features, independent input variable is being utilized. So that can also be a categorization of the data based on this. You also do this, right? And you also do this. Okay, you'll see that. Okay, now data type, if you are aware, character or string, and numeric, you can put it this, but this is hardly used in machine learning. Okay, machine learning, basically we use this also. I'll tell you where do we use this. Okay, we'll look into that aspect also. Now the point is that I'll just give you a brief where is this being utilized. Okay, so machine learning models, okay, are basically mathematics algorithms, okay, which are being used to build a model, right? And this ML algorithms which are going to build the model only accepts input in the form of numbers. Okay, they only accept input in the form of numbers. Whether it is ordered or non-ordered doesn't really matter. Discrete, continuous, ordered, non-ordered, all okay, but it should be number. Okay, if you have character, okay, like gender may be male and female. So what do you need to do first? You need to convert it into, tell me, convert it into numbers. You'll put something. Okay, similarly, married, unmarried, employed, self-employed, property area, status, and now we will look into what is this intuition. When we say 01, is it really a number or there is something else behind it? Okay, we'll look into, but we need to put it into numbers and then we'll look into that aspect. Okay. What do you understand by this word dispersion? Now let me just take you an example. I'll just explain you why this. Let me just explain. So we have, suppose I went to a city, okay, and I stayed in that city for 7 days and I was measuring the temperature of that city. Okay. Just look into first table right now. The temperature was 21, 20, 19. These are the values. Okay. So if I ask you to calculate the mean of this, you will find total is 140. Just do this. 21 plus 19 is again 40 plus 20, 60, 80, 100, and then it comes out to be 140. So if I ask you what is the mean, you will say 20. If you arrange it in a sequential order, though it is, if you arrange it in a sequential order, you will get the median also 20. Now, there is one more person who went ahead and took the temperature and he found the value. Again, the average is coming out to be 140. That means mean is 20. Median, coincidentally, median is coming out to be 20. Example, okay. Again, we have some temperature taken by third person. He also found mean to be 20. Even the median for this also comes to be 20. Now, my point is, are these values same or different? Because mean and median are equal. Tell me, like, are this data being taken for the same city or for the different city? What do you think? Across the same days. That means consider 23rd Jan to 29 Jan. So what do you think? Are these values of the same city or different city? Can we have in the same city, in the same zone, can we have this much temperature variance? Think about it. The minimum is 90, maximum is 21 here. So if I ask you what is the range of this value? 2, right? Maximum minus minimum. If I ask minimum is 70, maximum is 23. What is the range? 6. And if I ask you what is the value here? 11 and 31 is the maximum. The range is 20. That means all the values are of different cities. But if you would have gone by mean and median, you would have thought that everything is same. Because when you get the data, right? When you really get the data, do you think that you're going to go ahead and look into each and every value, or are you just going to look into the stats? You look into the stats, right? What if you look into the stats and you categorize everything to be same? That will not make sense, right? You're trying to suppose build a system which is going to predict the temperature. Okay, which is going to predict the temperature of a city. And suppose you have got these three kinds of values, 21 values you have got in your system, and some are having a range of 2, some are having a range of 6, and some are having a range up to 20. And you have combined everything together. Three people went ahead and calculated, collated the data from their sources and gave it to you. And then you went ahead and combined all these three and created a machine learning model. And you're using it in the city. Do you think it is going to give you the correct temperature value for a same city? Because this is being taken across three different cities. We can see that. Okay. So that is where dispersion comes into picture. Dispersion is again a way of measuring spread in the data, which is not being measured by mean, median, mode. Okay. For that, we have other terms like variance, standard deviation, percentile, range, and interquartile range. Okay. This gives you measure of dispersion. How do you start with dispersion? You try to find the range. If you remember, I already told you range. So if you see, suppose three people have collected the data, you will try to find the range. Okay. So you don't even know which city they are from, right? Okay. Suppose you have got the data, right? So for that, you can first find the range, and there are other dispersion techniques also. Has anyone heard about variance, standard deviation, percentile, similar to this earlier? No problem. If you have not heard, you'll hear it right up. Okay. Just to keep it simple, we'll look into not detailed mathematics, but whatever is required for us to understand the data. Okay. Because all these things really matter when you will try to build a machine learning model after this session. Yeah, or after this course, when you will sit down, all these things will matter because you will analyze the things, right? You will try to understand the things. Okay. Before you go ahead and build a model, you need to pre-process. And for this, all these terms are important. Even at the time of evaluation of model, all these things are important. This will keep on playing in your mind. So we'll look into this once we come from the break in next 10 minutes. Okay. So when we want to understand dispersion, we need to understand this terms like variance, standard deviation, and there are others also, but we'll keep focused to percentile, interquartile range, and then we can jump on to the graphical perspective of this. Now, when we say variance, what is the difference of variance and standard deviation? First of all, root of variance is nothing but standard deviation. Okay, so if we take root of variance, we call it a standard deviation. Variance is generally represented by sigma square. Okay, because it does take square into picture. And root of variance is what we call standard deviation, so it is nothing but sigma. So when we want to calculate variance, we call it by sigma square, and when we want to calculate standard deviation, we call it by sigma, which is root of variance. So basically, when you calculate variance, you take root and you get standard deviation. Now, what is variance? Variance is one of the way to measure the spread in data. So if you remember our data, okay, so for different cities, if you remember one of the city wherein we had the range of only 2, the minimum and maximum difference was coming out to be 2. So if I want to find variance for this, variance basically means first take the average of this. So average of this is going to be 140 by 7, which is 20. So do a subtraction of each value. X minus x bar, 20 minus 20 will be 0. 21 minus 20 will be 1. 19 minus 20 will be minus 1. So you try to find all this value. Then you take a square of this. Here the data is pretty simple, guys. But this is not like always going to be 1 and minus 1. So if you try to add it here, this has been taken for a purpose. If you try to add it here, what do you think will be the value? What will come out if you add it here? 0, right? So if you add it, negative and positive can play that effect, right? That's the reason we take a square so that we can eliminate the negativity. So we can eliminate the sign preference. It's important to eliminate the sign preference. That's the reason we take square. Okay, so it's not only finding the deviation of each value from the mean and then taking a mean of it will not solve the issue. So finding the value deviation from each value, okay, finding the each value deviation from the mean and then taking a square will do one thing. First of all, we'll get an effect of each value, how much far it is from the mean. Okay, then we take a square to eliminate the effect and then we take a summation of this. Okay, then we take a summation of this. So now if I take a summation, it will come out to be 4. But our first aim was to eliminate the effect of sign signature. Okay. Apart from that 4, now, so this is summation. Now, if I say how many values are there? 7. So 4 by 7 will be what? 4 by 7 will be average of this. This is what we call variance. So remember it by heart. Variance is x minus x bar whole square. Then you take a sum of it and then you divide by total value. This is called as variance. Is it clear? It will give you a clear picture of how each value is deviating from its mean, and then you take a sum of it. So variance is coming out to be how much? 0.57. If you take a root of it, you get a standard deviation. Guys, is this part clear? X bar is basically 20 plus 21 plus 19 plus 20 plus 21 plus 19 plus 20 divided by total number of observation, 7. Mean. X bar is mean, right? The way you calculate mean. Okay. What is X bar? Tell me. Of the data. 20, right? So you take first value, subtract it from here. What do you get? X bar is how much? 20. So you 20 minus 20, 21 minus 20, 19 minus 20, right? Is it okay? X bar is the way to represent mean in maths. Okay. Now, what are we trying to find? I'll help you understand, guys. The purpose is not to study maths. The purpose is to study data. So we knew for this data, what was the mean? 20. And what is the standard deviation? 0.75. Do not try to infer anything right now. This is just a number. Okay. Now let me take you through this. I hope you remember this city. What was the range here? You remember? Range was 2. We just did it right away, right? So we got this for the same thing on this sheet. We have this, right? So we have just put it here. So for this, where the range was 2, what is the standard deviation? 0.75. And for this city, the last city, if you remember, where the range was 20, we are getting a standard deviation of 7.67. Now, if I ask, are this both the data same or different? Tell me. Data is different. If you would have looked at mean, you would have told the data is same, right? Which is not correct. If you look at standard deviation, you would have told no, the data is not same. Is it okay now? Either you look at standard deviation or variance. What is standard deviation? Root of variance. Standard deviation comes from variance. Is it okay, guys?
Yep.
Yes.
So now don't go by this value. Every data will have different values, guys. Every data, sometimes 100 can be a value. I'm just giving an example. 100 can be a standard deviation. If you're trying to compare maybe 100 and 102, if I tell you 100 and 102, are this close or near? Tell me. One data is having standard deviation of 100, one data is having standard deviation of 102. So are this close or near? Sorry, close or away? Close. Done. So don't go by the value. If it is near to 0, then it is good. No, no. In our case, it was near to 0 because our data was like that. So the point is, now try to understand. If your range is, think about this. If your range is 0, what will be the standard deviation automatically? 0. Okay? Done. Think about it. If your range is 0, standard deviation will be near to 0. Keep it simple. Okay? Now I'll tell you why the range will be 0. Range can only be 0 if each value is equal. Yes or no? Yes. When will I have range as same? Minimum minus maximum, right? So when will I have range as same, guys? Think. When each value is equal, yes or no? Okay. Now, if each value is equal, average and value will be equal or not? If average and value is equal, what will be x minus x bar for every value? So square will also be 0. So don't you think standard deviation will be 0? Yes. So now I hope you understood and you can appreciate what is standard deviation. Okay. That doesn't mean standard deviation cannot have 1 lakh. Standard deviation can also be equal to 1 lakh. So basically, when you're trying to compare, try to understand what I'm saying. If you have 2 standard deviation, 3 standard deviation, okay, that means you're trying to compare if these two datas are same or not. Okay, if it is near to 0, well and good. But suppose if standard deviation is 100 and one standard deviation is 200, then also this are dispersed data, right? Both are not near to the center value and both are dispersed and both are different also. Both are dispersed and both are different also. Okay, guys. Now we need to understand. So we have just understood what is descriptive statistics, and we have just started and we have understood what are the different types of data variable and how do you categorize them. Now we'll look into something called a central tendency. Now, just to help you understand central tendency, let me give an example. Okay, just to show you, suppose if I ask you, where will, suppose these are the points that I've plotted. Suppose this is the age and this is the income of a person. Okay, we went ahead and plotted this data for different age groups. Okay, or different ages we plotted. Okay, after plotting, if I ask you where will the mean of this value lie, you know that the mean will lie somewhere in the center, right? You take a mean of everything, you will find it will be somewhere here. So the mean will lie somewhere here, right? Just to show you, suppose I'll just put it this way. Okay, suppose I'll just put it this way. Suppose this is histogram. This is for people who are 15-year age, then 20-year age, and just given this may not be the same. Okay, it can be up and down. But if I ask you where will the mean lie, you can automatically say the mean will lie where the maximum value resides, right? Where there are maximum of values, automatically mean will lie there only. So wherever there is a maximum value, you can say just take x bar, just to show you. Sorry, you take x bar, take x value of this, and take y value of everything. And when you will go ahead and take x bar of everything and y bar of everything, you will surely fall somewhere here. So this is what we call central tendency of data. Any data in the universe tries to follow a central behavior, wherein that automatically, if you try to find the center point, you will find that it will be somewhere across the value where there are maximum values, it will automatically attract that. Okay. Now, just to show you, for this, we have different types of measures like mean, median, mode, and there are others also which we will not look into because there are formulas that have already been derived. So we look into mean, median, mode. Okay, just to give an example, I have got a data, okay, of some people like Jitesh, John, friends, and this is a loan amount that they have asked for. Now, suppose my boss comes and says, what is the mean loan that people are asking for this month? Okay, mean value of the loan that people are asking for this month. So what are you going to do? You will take all the value divided by the number of people who have applied and you will say this is the mean, right? Then we'll change this question. Okay. Now suppose my boss comes and says, tell me what is the mean value of the people, okay, with respect to their gender. Can you say this? I'm not saying loan amount. Tell me the mean of gender. Is it possible to give a mean of a gender? Suppose this is male, this is male, this is male, everyone is male. I'm not sure about this. Maybe female, male, male. Okay. Now, if I ask you, tell me the mean of this. Can you ever say a mean of this? You cannot say, right? So for this, what will we prefer? We prefer something called as mode. Okay. Whenever. So we can take mode of number also, but we prefer to take mode of whenever there is category, we prefer to take mode. Okay. Mode of the highest value, mode of the lowest value, mode of something that is between highest and lowest. Okay. I hope that makes sense. Again, I'll repeat. Suppose I have got a data set, okay, wherein I have got 100 data points, okay, and out of that 100 data points, 80 are male, okay, 10 are female. Let me tell you, 10 are null, means they have not disclosed their identity. And suppose in world there are only two types of genders that exist according to them, okay, for whom they are going to give the loan. So if I ask how many males are there, you will say 10, 80. How many females are there? You will say 10. So if I ask you what is the mode, highest mode value, you will say which value has been repeated most. Which value has been repeated most? So this is the highest mode. Okay. Just to give an example, in this data, if I ask you what is the mode of this loan amount, you will say the most occurred value is 24,000. So people are looking for loan of 24,000 in the mode. Maximum people are asking for a loan of 24,000. Okay. If I ask you minimum, you will automatically check which is the minimum. If there are not more than one, you will automatically say the mode, minimum mode is 16,000. If there are repetition, you will automatically be able to say. Generally, you will have repetition. Now, the point is, why do we require this mode? When I want to fill this null value, right? Now, if I want to balance this data, okay, if I want to balance this data, whatever remaining are there, I can either balance it with, tell me, with the male. I can replace all the null people who have not specified the category as male, okay, or I can replace them as female, right? To have some balance. Is it okay? Now, how will you get a median of category? Median is again for number. Mode basically means when you want to work with category, and if there are some missing value, you can either see, you can either replace it with a lower mode or a higher mode, right? when you want to go ahead and replace the missing value of a category. Okay. I'll tell you this. Now tell me mean will be preferred when you want to replace the missing value of numbers. Okay. Now we'll look into something else. Median. Now what is median? I'm just helping you understand. Median basically means whatever you have arrange in ascending or arrange in descending. Here we are arranging it in ascending, lower to higher. After arranging, try to find the median value. This is where you when you go to website, you find median salary. What do you mean by this? People who are starting with 0 year experience to 30-year experience, we would like to know what is the median salary. This is what HRs or even we are looking for, right? What is the median salary after working there, right? Making sense what I'm saying? So median basically means arrange everything in ascending and descending and then try to find the median value. Okay. So we have arranged. Now, what if we have two values as median? Suppose there was one more, which is 50,000. And suppose this was the last 50,000 I have put in. And now when I say 50,000, this is eighth, right? So from here also 4 and from here also 4. So the median will be this plus this divided by 2. Is it okay? So 53 plus it will be 26.5, right? So if someone asks me what is the median salary, you can say 26,500 for a person who is having an experience of at least 4.5 years. Okay. Just wanted to help you understand mean, median, mode. This all things are very important when you look into the data. So just to give an example, I help you understand mean, median, mode. So if there are missing value, you can play with mean, you can play with median if there's a number, discrete or continuous. But if it is a category, then you will go with mode because you cannot, just to give an example, if I have a category of low, okay, low temperature, high temperature, okay, I'll just give an example. Low is being represented by 0, high is being represented by 1. Now, can we have a temperature, can we have a category that we can say 0.5? Can we say? So even if it is 0 and 1, can we ever say that we can impute it with 0.5? Will it make sense? No, right? 0 plus 1 divided by 2 will not be a category, right? I hope that makes sense, guys. So you will either replace it by mean or you will either replace it by, sorry, you will either replace it by mode. There is no other option. Okay. Now let me just take you ahead with outlier. Now I'll just give an example of outlier. Just look into this. So there are people who 1 year of experience to 15 years of experience in my organization, but there is one person. Just give an example. Suppose this is the salary of each and every average salary, okay? Or suppose there are only 15 employees in my organization. Suppose, okay, and each one is having this salary. Now here you can see the salary is there, which is all fine. Here also we have salary, but this person was a genius. Okay, this person was a genius. Okay, he was having a salary of 19,000, far more than people who have 15 years of experience. Even before him, after him in experience, there was no one who was, maybe he was Bill Gates. Okay, just to give an example. Now, if I try to plot it, okay, with respect to experience and salary, you will say everyone is following a linear curve, right? But this person is going ahead and coming here. He is an abnormal thing for this kind of evaluation. You have that odd man out, right? You say that you are out of league. We do not consider you to be the part of our category, right? That is what we call outliers, right? Outliers are generally extraordinary, right? Okay, just to keep it simple. So when you want to go ahead and suppose if I ask, what is the mean salary? Okay, what did I ask? If I ask what is the mean salary, now tell me, will this value impact the mean or not? Why do we need to take him or her out? Because this is actually disturbing the norms. People aren't earning that much. But if keep him into the system, they will get a false assumption that this is the salary that we get here, right? Just to give an example. Okay. So that is the effect of outlier. Just to keep it simple. We have got the two data wherein just look into this example number 10. We have just replaced this. Okay. Now, if we check this here, okay, the mean value. See, just look into this. The median for both is coming out to be 7,200. If you arrange, this is already arranged, I guess. You can check it out. I think it is already arranged. So the median is coming out to be what? 7,210. For both the medians are correct. But when you look at the mean for this, you find that no, it is very different. I hope that makes sense. So median can give you a picture of the mid value. It will not give you a picture of the mean things that are happening. Okay. So if you want to understand the effect of outlier, you should never go by the median thing. You should always go by the mean. Okay. Try to eliminate that person and check what is the mean. Okay. If there are multiple outliers, you can remove and check. Okay. Outliers can also be people who are having low salary. It can also be people who are having high values. It's not just outlier can be at the up. It can also be at the bottom, right? I hope that makes sense. See, I'll just keep it simple. You take mean. Okay. You can replace any numerical data which is discrete or continuous with either mean or median. It's your choice. But when you want to check for outlier, okay, suppose you found that there are 400 values which can contribute to outlier. Suppose you got this kind of a curve. So you eliminate these values and then check for mean with and without that. I hope that makes sense. And then if you see that the effect is very huge, you set some tolerance, like maybe 5-10%, 5% is okay. If you found that the effect is huge, here the effect is pretty huge. 7,000 to 7,800 is around, you can say around 12-13%, right? Of effect is happening. So you can like to eliminate. So just to give an example, maybe Bill Gates at the age of or at the experience age of 25 was having 1 million or $1 billion, just to give an example. So this person was an outlier. It should be not taken into consideration when we want to analyze this kind of a system, because it can give again overfitting information to the model. Okay, it can either overfit or underfit. Okay, or it can hallucinate. Maybe it is going to give unclear picture. Okay, at the time of prediction. Fine.
And that's a wrap on today's deep dive into data analysis. If you want to dive deeper into AI and machine learning and learn how to apply these skills in real world scenarios, don't forget to check out our free masterclass. Link is given in the description below. Also, make sure to comment below if you have any questions or want to see more tutorials on data analysis. Thanks for watching, and make sure to watch our Python series over here.